Hello students, welcome you once again to GK's maths classes. Today we are going to do relations and functions. This is the third video that we are putting on relations and function, where we are going to do problems in relations and functions. Already in part 1 of the video I have discussed the concept of relation, or what are the different types of relation, and in part 2 video we have done some problems, and I also discussed about equivalence class. So I will put the description of both the videos in this video, so that if you have any clarification you can always do it. Okay, shall we straight away get inside the class? Okay, now for the first question here is, before we go, just a brush up of what we have done. So S is a non-empty set, is a non-empty set, and R is a relation. R is a relation on S, and if for every A belongs to S, if A comma A, if every element is related to itself, you call that relation as reflexive relation. Okay. Already we have done this, just I'm reminding you about it. For every A comma B belongs to S, if A is related to B, then you can say B is related to A. If that is the case, you can say R is symmetric. And I also said for every A comma B comma C belongs to S, if A is related to B and then B is related to C, you can say that if you get A is related to C, then R is transitive. And in the course of the class I also said that even if one of them is true, like if I have A comma B belongs to R, and if I don't have B comma C belongs to R, if we don't know, still you can say the relation is transitive. Okay. Then we talked about equivalence class. So what is equivalence class? If I have S is a set, it is basically partitioning the set into different subsets. Let me take it as 3 subsets, for example. Partitioning it to 3 subsets, where if you put them together you get the entire set, and none of them have anything in common. Is null set, is null set, then A2 intersection A3 is a null set, and A1 intersection A3 is a null. I just took it for convenience 3 sets. You can have any number of sets. So it's basically this A1, A2, A3 partitions the set S into 3 disjoint subsets. Okay, so that's what we discussed. Okay, now we'll do some more problems. Already we did few questions. Today we'll be covering more questions on relations and functions. And these are all very important questions. It has come in the board exam also. If A is a set, here my set is, it's given as 1 to 9, 1, 2, 3 up to 9. And the relation R, the relation is not defined on A, the relation is defined on A cross A. It is defined on A cross A to A cross A. So every element in A cross A will be an ordered pair. Okay. So that is why A comma B related to C comma D. How is it related? A comma B related to C comma D. How is the relation defined? The extremes are added, that is A plus D equal to the sum of the, like a mean, B plus C. A plus D equal to B plus C. A plus D equal to B plus C. Now I want to verify whether this relation is an equivalence relation or not. If I want to verify whether it's an equivalence relation or not, I have to verify whether it is reflexive, symmetric and transitive. So first of all, let's go to reflexive. So how many elements I should choose? I should choose one element. Where should I choose? I should choose it from A cross A. How will an element in A cross A look like? It will look like an ordered pair. So this is not 2 elements, this is 1 element. Where does it belong to? It belongs to A cross A. For every A comma B belongs to A cross A, well, I don't know what to do after that. So I have a different way of doing these problems. I go backwards. What I want to prove? I wanted to prove A comma B is related to A comma B. If I am able to prove that A comma B is related to A comma B, I can say it's reflexive, isn't it? Now this is what I want. If I want this, what should have been my previous step? My previous step should have been, what is that? A plus B, by the definition, A plus B should be equal to B plus A, correct? A plus B equal to B plus A, correct? So what should be my assumption then? Obviously, A plus B should be equal to A plus B. It is possible A plus B is equal to A plus B because A and B are natural numbers. Okay. Relation on A, I think I have not said what A is. Okay, A is here. 1 to 9. Okay. So A plus B will be equal to A plus B. But you know, in set of natural numbers from 1 to 9, addition is commutative. So A plus B is same as B plus A. So you are pretending as if you are going from top to bottom, but actually I went it reverse. So how do I know I have to start with A plus B equal to A plus B? So that is why I went backwards. Okay. You can even go this way, it's not a problem. That finishes reflexive. Now what is symmetric? How many elements I should choose? I should choose 2 elements. What are they? A comma B and C comma D belongs to A cross A. I am choosing 2 elements, A cross B, A comma B and C comma D belongs to A cross A. Now, if A comma B is related to C comma D, if A comma B is related to C comma D, that means what do you know? That means A plus D, this is known to you from the definition, is equal to B plus C, correct? From the definition you know it. Then what I wanted to prove, I don't know. So I wanted to prove C comma B D is related to A comma B. If I prove this, then we can say it is symmetric, right? Let us see whether it's possible or not. So that means what I should have got in the previous step? I should have got C plus B, right? C plus B equal to D plus C. This is what I should have got. Which is obvious because see, A plus D is B plus C means I can say B plus C equal to A plus D, correct? I can reverse, it's an equality, so I can put A equal to B means I can write B equal to A. Now B plus C, B and C are 1 to 9, so they are commutative. So B plus C is same as C plus B and A plus D is same as D plus A. Hence proved. Therefore R is symmetric. Here R is reflexive. Now finally, what is the last step? I have to prove that R is transitive. So for every A comma B, C comma D and E comma F belongs to A cross A, if I choose 3 elements, what I know, if A comma B is related to C comma D, C comma D is related to E comma F. So from this what do you know? You know that A plus D equal to B plus C by definition, and I call this as 1, correct? Then C plus F equal to D plus E, this is again by definition, I call this as 2. Now what is that I wanted to prove? I wanted to prove, if I want to prove transitive, that A comma B is related to E comma F. If I want to get this, what I should have got in the previous step? I should have got A plus F, correct? A plus F equal to B plus C. This is what I should have got. A plus F equal to B plus C. Now what I will do? For that I take 1 plus 2. What is 1 plus 2? A plus D plus C plus F, A plus D plus C plus F equal to B plus C plus D plus E. Just normal addition. Okay. Now clearly D and D cancels, C and C cancels. You have got A plus F equal to B plus C. Hence proved. Correct? Fine. Therefore R is transitive. Once R is transitive, it was reflexive, symmetric and transitive. Therefore R is an equivalence relation. Clear? Now there's one more part which is very, very important. This alone can be asked for 1 mark or 2 mark question. So what is the equivalence class of 5? So what is the equivalence class of 2 comma 5? So what are the set of all elements in A which are related to elements in A cross A which are related to 2 comma 5? So what I will do, for every A comma B, it has to be related to this, right? So 2 comma 5 is related to A comma B. I want to find the suitable A and B. Okay. So by definition, you know, it is 2 plus B equal to 5 plus A. By definition, 2 plus B is sum of the extreme equal to sum of the mean. 2 plus B equal to 5 plus A. So what is B equal to? B is A plus 3. Right? So now what do you do? When you put A as 1, you get B as 4. Right? When A is 1, B is 4. When A is 2, B is 5. When A is 3, B is 6. When A is 4, B is 7. When A is 5, B is 8. When A is 6, B is 9. When A is 7, B will be 10. 10 is outside this. So what? How do I write the answer? Therefore, I don't have a place. So I will write the equivalence class of 2 comma 5 is, and put it in bracket. What is that? 1 comma 4, and then 2 comma 5, then 3 comma 6. Separate them by commas. Okay, 3 comma 6, 4 comma 7, 5 comma 8, and 6 comma 9. So this is the equivalence class of 2 comma 5. Very, very simple problem, but it is slightly lengthy. But they have asked these type of questions in the board exam. Even though these are not there in the NCERT book, these type of questions are very, very important. Okay, let's go to another question which is something similar, but there it was A plus D, here it is AD and BC. So not a big complication. So let us see. Now I want to verify reflexive. Okay, I will verify reflexive first. I'll take the black. Reflexive. So how many elements I should choose? I choose one element. Where should I choose? I should choose it from A cross A, because the relation is from A cross A. Your relation is defined on A cross A, just like the previous problem. Now, what I wanted to prove, I have to prove that A comma B is related to A comma B. Here also I go a little backwards. Not that it's difficult to go from here, but this is easy. You don't have to waste your time to think. So you get AB equal to BA, correct? AB equal to BA. So obviously, you know, AB equal to AB. Why? Because A is n is set of all natural numbers, okay? And actually it should have been A set of all natural numbers, okay? A, not n. It should have been n, A set of all natural numbers defined on the relation. So this is actually n cross n. So each and every element A and B are natural numbers. You know, product of two natural numbers is commutative. So AB is same as BA. That is why I got this. So now you can say R is reflexive. Clear? Now let's go to symmetric. For symmetric, how many elements I should choose? I choose two elements. What are they? For every A comma B and C comma D belongs to A cross A. For every A comma B and C comma D belongs to A cross A, what do I get? I have, if A comma B is related to C comma D, this implies AD equal to BC. This is by definition, you know. Now I wanted to prove that C comma D is related to A comma B. How do I do that? What I should have got? I should have got CB equal to DA. I should have got CB equal to DA, which is very, very obvious, because if AD equal to BC, we can always write this as BC equal to AD. Once I write BC equal to AD, BC same as CB, AD same as DA, because multiplication of natural numbers is commutative. When I say A cross A, that means it is n cross n because A is taken as natural numbers. Now, what is transitive? Transitive relation. For every A comma B, C comma D, E comma F belongs to A cross A, if A comma B is related to C comma D and C comma D is related to E comma F, then what do I know? What we know? We know that AD equal to BC by definition. Call this as 1. What about this? CF equal to DE. Again by definition. Correct? Now what I wanted to prove? I wanted to prove that A comma B is related to E comma F. That means what I should have proved? I should have got AF equal to BE. Let us see whether it's possible. There I added, so here what you do is just multiply 1 and 2. So what do you get? AD into CF equal to BC into DE. So clearly D and D cancels, C and C cancels, you get AF equal to BE. Straightforward, simple question. Therefore R is transitive. Once R is reflexive, R is symmetric, and R is transitive, what type of relation is R? R is an equivalence relation. That finishes the first part of the question. Prove that R is an equivalence relation. Also obtain the equivalence class of 2, 6. So just like what we did before, let us choose 2, 6 and we'll allow it to relate it to an element A comma B. Here A comma B belongs to A cross A. Now how is the relation defined as? The relation is defined as 2B equal to 6A, correct? 2B equal to 6A, product of the extreme equal to product of the mean. So what is B equal to? B equal to 3A, right? So since it is an infinite set, I don't want to list out the elements, so I will write my equivalence class of 2, 6 will be elements of the form A comma B such that B equal to 3A for every A comma B belongs to A cross A. Either you can write like this, or if you want to list out the elements, I don't have a problem. All that you need to do is, when A is 1, B is 3, correct? When A is 2, B is 6. When A is 3, B is 9, and so on. So either you can list out like this or like, since it is an infinite set, it's better to write like this. So this will like cover everything, otherwise you have to put dotted lines. Okay. Let's go to the next question. Here, I hope you understood the previous question. Let's go to the next one. Okay. First we have to verify reflexive. For every A comma B belongs to A cross A, what I should do? I should verify whether A comma B is related to A comma B. Now how it is defined? That means I should have got AB into B plus A, correct, equal to BA into A plus B. This is what I should have got, which is very obvious because you know AB into A plus B is same as AB into A. This is how I will start the problem. B plus A is same as A plus B is same as B plus A because addition of natural numbers is commutative, and AB is same as BA because product of natural numbers is commutative. Therefore R is reflexive. By now you should have understood the process, okay, reflexive. Now I want to prove symmetry. How many elements I should choose? For every A comma B and C comma D belongs to A cross A. For every A comma B and C comma D belongs to A cross A. If A comma B is related to C comma D, what do you know? You know AD into B plus C equal to BC into A plus D. By the definition, see, AD into B plus C is equal to BC into A plus D. What I wanted to prove? I wanted to prove that C comma D is related to A comma B, right? That means what I should have got in my previous step, CB into D plus A, correct? CB into D plus A equal to DA into C plus B. By the definition, see, CD into D plus A equal to DA into C plus B, which is so obvious because I can always write this as BC into A plus D, exactly like what we did in the previous problem. Now BC is same as CB, A plus D is same as D plus A, AD is same as DA, B plus C is same as C plus B, hence proved. R is symmetric. Correct? Now how do I prove transitive? There you slightly have to think. For transitive, for every A comma B, C comma D and E comma F belongs to A cross A. If I choose three elements, A comma B, C comma D, E comma A belongs to A cross A. If A comma B is related to C comma D, that means what do you know? You know AD into B plus C equal to BC into A plus D. Okay. Now you also know that C comma D is related to E comma F. That means what do you know? You know CF into D plus E equal to DE into C plus F. Okay. CF into D plus E, DE into C plus F. Perfect. Now what I wanted to prove? I wanted to prove that A comma B is related to E comma F. If I want to prove this, what I should have proved? I should have proved that AF into B plus E equal to BE into A plus F. Correct? AF into B plus E is BE into A plus F. This is what I should have proved. Now how do I go about it? Now look at this expression. So can I say this is B plus C by BC equal to A plus D by AD? I just cross multiply. B plus C by BC equal to A plus D by AD. Correct? I brought this AD down, I brought this BC down here. Now you split this. What is B by B plus BC? B by BC will be 1 by C. Correct? And what is C by BC? It will be 1 by B equal to, what about this? 1 by D plus 1 by A. Call this as 1. Okay. Same thing you do for this also. What you will do? You will bring DE down and CF this up. Okay. Now you split it. How do you split it? 1 by E, because D by DE is 1 by E. E by DE is 1 by D equal to 1 by F plus 1 by C. Call this as 2. Now what do? You do 1 plus 2. When you do 1 plus 2, you get 1 plus C plus 1 plus B plus 1 plus E plus 1 plus D equal to 1 by D plus 1 by A plus 1 by F plus 1 by C. Clearly, 1 by C and 1 by C cancels, 1 by D cancels. Now what is the LCM here? Here the LCM is BE. What do I get up? I get B plus E. And what is the LCM here? AF. So what do I get up? You get A plus F. Now if you cross multiply, you get this. Hence proved. Therefore R is transitive. Therefore R is an equivalence relation. These three problems that we did today all three are very, very, very important questions. Even in this year board exam, one of them was asked. So all these three problems are very, very important. So please make sure you go through these problems very carefully. Even these problems are not available in the NCERT book. Now we are going to do, this is not proving, okay, where we are going to verify whether the given function is reflexive, symmetric or transitive. Now in mathematics, if you want to prove a result, you have to prove for all values. Okay? If you want to prove something, you prove for all values. But if you want to disprove, you just give one counter example. The moment you give a counter example and you say it's not true, then that result cannot be true for anything. Okay? So it doesn't matter whether it's true for infinite values, but if it is not true for one value, then that result is not true in general. Okay? So whenever you want to disprove, give an example. Whenever you want to prove, you prove for all values. Okay? So let us see how to go about this problem. The relation is, my set is set of all real numbers, my set is set of all real numbers, and my relation is R. My relation R is defined from set of all real numbers to set of all real numbers. And how is the relation defined? The relation is defined as A comma B such that A is less than or equal to B square. And he wants me to verify whether it is reflexive, symmetric and transitive. In this problem, I have already asked you to show whether it's reflexive, symmetric or transitive. But generally they'll say verify. If they say verify, then there's always an element of doubt. It can be true, it need not be true. But here you know definitely it can't be reflexive, it can't be symmetric, it can't be transitive. Now how do I give example? Now I'm going to talk about reflexive. Reflexive. See the example I'm taking. Half is a real number, am I right? Half belongs to real numbers. And you know very well, half cannot be less than half square, correct? Because half is 0.5, 1 by 4 is 0.25. Okay, so definitely half is greater than half square. So clearly, half comma half does not belong to R. Okay, because the relation is A should be less than B square. If you want A to be related to itself, I should have got A less than or equal to A square. But I cannot have A less than or equal to A square if A is half. You can take some other examples. You can take even 1 by 3. Okay, so half comma half do not belong to R. So you have proved that R is not reflexive. R is not reflexive. Okay. Now, how do I prove it's not symmetric? For that, you again take an example. Now, what example will I choose? Let me choose an example like half comma 1, which belongs to real numbers. Clearly, you can see half comma 1 belongs to R. Why? Because half is less than 1 square, correct? Half is 0.5, 1 is bigger. So half is definitely less than 1 square. But 1 is not less than half square, correct? 1 is bigger. Therefore, 1 comma half do not belong to R. Therefore, your half comma 1 belong to R. If you want symmetric, 1 comma half also should belong to R, because if A is related to B, then B should be related to A. Here B is not related to A. So you are given an example where it is not symmetric. Therefore, R is not symmetric. You don't have to prove for the result. If you give one example, that's it. It cannot be true. Okay. Now I have to talk about transitive. For transitive, let me take 3 numbers belongs to. You can take any example. I have taken some example. You can take any example you want. Suitable example where you can disprove. Okay. Clearly, you can say 2 comma minus 2 belongs to R, isn't it? Why? 2 is less than minus 2 square. Minus 2 square is 4. So obviously 2 is less than 4. Minus 2 is less than, you can say minus 2 comma 1 belongs to R. Why? Minus 2 is less than 1 square, because negative number is less than the positive number. But you can see very clearly 2 is not less than 1 square. You should have got 2 is related to 1. It doesn't happen. 2 comma 1 does not belong to R, this implies R is not transitive. So I give examples to disprove the results. So when you want to disprove something, give an example. Whereas if you look at the previous three problems, it was true for all numbers. That is why I proved it there. For proving, it's a formal proof. For disproving, just give an example. Is it clear? Now there's another version of this question. This is previous was an NCERT question. This is also an NCERT question. Let us try to do this. Here also, what is my set? My set is set of all real numbers, and R is a relation on real numbers. Correct? How is it defined as? The relation R is defined as A comma B such that A is less than or equal to B cube. It is B cube. Okay? And here if they have told like this, if they ask, there's a doubt whether it is reflexive, symmetric or transitive. So I need to give example. For example, for half, same example I take, belongs to real numbers. Clearly half cannot be less than half cube. Why? 1 by 2, this is 1 by 8. So obviously the denominator, when it becomes more, the fraction will be less. So clearly half comma half do not belong to R. This shows that R is not reflexive. Okay. Now I have to give an example for not transitive. Now what example will I take for not transitive? I'll choose the same example, half. I will choose half, half comma 1 belongs to R. Clearly half comma 1 belongs to R. Why? Half is definitely less than 1 cube, but 1 is definitely not less than half cube. This shows that 1 comma half do not belong to R. Therefore R is symmetric. I took same example so it's easy for you to remember both the problems. Okay, so I hope it's clear. Now the third one, it's a little complicated. You need to think a lot. 3 by 2 and 4 by 3. I have taken this example. You can take any example you want, which is suitably disproves the result. Belongs to R. So clearly 3 comma 3 by 2 belongs to R. You can even choose cube root of a number. That makes it easier because it is B cube, right? So if you can 3 power 1 by 3, like that also you can take. But that will be difficult to comprehend. So I have taken numbers that are very familiar to us. So 3 is definitely less than 3 by 2 the whole square. 3 by 2 the whole square is 9 by 4. 9 by 4 is 2 point something. So 3 is definitely, sorry, it's cube, no? I'm sorry, I made a mistake. Cube, so it is 27 by 8. 27 by 8 is more than 3. So 3 is definitely less than 3 by 2 the whole cube. Now, you also know 3 by 2 comma 4 by 3 belongs to R. That means what? 3 by 2 is less than 4 by 3 the whole cube. 4 by 3 the whole cube is 64 by 27. Okay. So 3 by 2 is 1.5. And 64 is more than double of 27. So this will be 2 point something. So definitely 3 by 2 is less than 4 by 3 whole cube. Am I clear? 3 by 2 is 1.5. 4 by 3 whole cube will be more than 1.5. But what happens? 3 is definitely not less than 4 by 3 the whole cube. Because 4 by 3 whole cube is 2 point something. But 3 is greater. So 3 comma 4 by 3 do not belong to R. Therefore R is not transitive. You understand this? So through examples you can understand that relation is not reflexive, symmetric and transitive. If you want to disprove, give an example. Again I'm repeating, to disprove, give an example. Now the next question. Check, this is again an NCERT question. Check whether the relation R defined in the set 1, 2, 3, 4, 5, 6. Okay. Your set is, I'll call this a set A, which is 1, 2, 3, 4, 5, 6. R is a relation on A to A. And how is the relation defined as? It's defined as A comma B such that B equal to A plus 1. So let us find out what is the relation R is. Relation R is when A is 1, B is 2. When A is 2, B is 3. Then it is 3 comma 4, 4 comma 5, and then 5 comma 6. I can't go beyond this because when you put A as 6, you get B as 7, and it is not there. Okay. Now clearly 1 comma 1, okay, 1 comma 1 does not belong to R. If you want reflexive, you should have had 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. All the elements should have been there. You should have got 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6. All the elements should have been there. But none of them are not there. None of them are there. None of them are there. Therefore, R is not reflexive. Okay. Now let's go to symmetry. For symmetric, what happens? If I choose 1 comma 2 belongs to R, if 1 comma 2 belongs to R, clearly 2 comma 1 is not available. Therefore, R is not symmetric. Perfect, isn't it? R is not symmetric. Let's look at transitive. For transitive, I'll give an example. 2 comma 3 belongs to R, correct? 2 comma 3 belongs to R. 3 comma 4 also belongs to R. But 2 comma 4 do not belong to R. There is no 2 comma 4. Therefore, R is not transitive. So this relation is neither reflexive nor symmetric nor transitive. Simple example, but this will give you complete understanding of the problem. If you wanted reflexive, all the 6 elements should be related to itself. All should be there. If you just have 1 comma 1, it's not sufficient. 1 1 to 6 6 must be present. Since it is not there, I say it's not reflexive. And symmetric means what? A B should be related to B A. So A is related to B, B is not related to A. If A is related to B, and if you have B is related to C, definitely A should be related to C. It's not there, so it's not transitive. So it's an example of a relation which is neither reflexive, nor symmetric, nor transitive. Okay. Now, this is again an NCERT. This is not from NCERT, but it's a very, very important question. R is a relation on set of real numbers. R is a real number, and R is a relation from R to R. Now is it defined as R equal to A comma B such that 1 plus AB is positive. 1 plus AB is positive. Now let's look at reflexive. For every A belongs to real numbers, clearly 1 plus A into A is positive. Even if A is 0, 1 plus 0 will be positive. Okay. So clearly A comma A belongs to R. This implies R is reflexive. Okay. Now let's go to symmetric. When I go to symmetric, for every A comma B belongs to R, if A comma B belongs to to the relation, this is real numbers, this is relation, 1 plus AB is positive. If 1 plus AB is positive, obviously 1 plus BA will also be positive. 1 plus AB is positive, 1 plus BA also will be positive. This implies B comma A belongs to R. Once you have B comma A belongs to R, you can say R is symmetric. So you got an example of a relation which is reflexive and symmetric. Now I am going to talk about transitive. Now what do I do with transitive? Let me take an example. Let me take say 3 examples. I will take -1, 0 and 2 belongs to real numbers. So clearly -1, 0 belongs to R. Why? 1 plus minus 1 into 0 is always positive, correct? Also you can see 0 comma 2 belongs to R. What is that? 1 plus 0 into 2 is also positive. But 1 plus minus 1 into 2 is not positive because it's a negative number. So minus 1 comma 2 does not belong to R. This implies R is not transitive. So we got an example of a relation which is reflexive, which is symmetric, but not transitive. I hope you understood all these problems. We'll do more problems in relations, okay, in the next video. Kindly subscribe to my channel and also click the bell icon. I hope you enjoyed this class. If you have any doubt, you can always clarify in the comment section. Have a great day. Bye bye. Thank you.